Hello, hello guys. Hi everyone. Hi again. So now we are going to look on to some new problem, which is called the best time to buy and sell stock problem. It's a very interesting and very famous problem to look on. So yeah. What this problem is all about? Let us just talk about that. So here we are given an array called prices. So here we are having this array. So what this array is all about, here this array stores the prices of the stock of every single day. Like on the first day the price of the stock is 7, but for the second day it's 1. It goes down to 1, and on the third day it's 5, and on the fourth day it's 3, and so on. So it stores the prices of the stock of on every single day. Uh, so that's this array called prices all about that we are having as an input. So now what we need to calculate is we need to calculate the maximum profit that we can get by buying and selling the same stock on which day. We don't need to calculate the which days, like on which day we will have the maximum profit, but what mainly we need to calculate is the maximum profit that we can get from any array of this prices of stock. Okay, so here, like in this example, as we can see here, the maximum profit that we can get is 5 when we give when we pass the input of when we pass the input as this array, which signifies is the prices of that stock value. Then then the output that we got is 5. 5 is the maximum profit. Like here you can see, if we buy the stock on second day and will sell at the fifth day, then only we will have the maximum profit, then only we will get the maximum profit, and the value of that maximum profit will be 5 only, because we are buying the stock at 1 and we are selling at the price of 6. So 6 minus 1 is 5. Okay, here in the second example also you can see that the maximum profit that we can get from this array is 0, because like every day the stock price went down. So we can't just like buy, and we can't just get any profit from this array, because every day the price is decreasing, obviously. So yeah, no transactions are done, because the maximum, like we can't even get any profit, so the profit will be 0 itself. So first what we need to do to solve this problem is, so yeah, so here we have two approaches. So the maximum profit value will be 0 only if we can't get any profit. So yeah, so that is the case. If we can't get any profit, then the maximum profit value will be 0 itself. So yeah, we need to maximize our profit by choosing 2 days, one for buying the stock and the second for, and the different day for selling the same stock. Okay, so it's a very simple problem and we can solve it by two ways. The first way is the naive approach. The naive approach mainly signifies the not so optimal approach. It is like worst case approach that we can use to solve any problem. It's the it's the brute force approach. Okay, the brute force means like we are checking everything to get the optimal value, not the most optimal solution. Okay, so yeah, In this brute force approach, we will try to check every case, like every possibility. We need to check that by which value, by which pair we can get the maximum profit. Okay, so for this array we need to check it for every single pair. We need to first create a pair and then check the profit value for every single pair. So uh, so let's first try to solve this problem. So first we need to initialize a variable called maximum profit, which will first have the for which we will assign first the value as 0, because right now uh, we are letting it just 0 only, because right now we are having the maximum profit as 0. So we will now try to run a loop for the buying day. So what we will do in this naive approach is we will run two loops, one inside the other. So the first loop will iterate through uh, this array to to get one to look into some buying day. For some buying day we'll need to run a loop to choose from. Okay, and for each buying day we will need to iterate a second loop which will run just after that, to see if we can, like, what or which day we can have the maximum profit. Okay, so the first loop will be for the buying and the second loop will be for the selling. Okay, one inside the other. So first we will start with the buying day. uh, this is the normal loop that we uses. And one thing I need to uh, say, that for buying day we don't need to run the loop from here till the last element, because the last element, like, we can't just buy the stock at the last day, because we will not be able to set it. So what's the thing in buying it? Okay, so it's logical only. So there is nothing to uh, uh, earn from by buying the stock at the last day itself. So that's why we need to run this loop till the second last day itself. That's why we are using -1 over here. Okay, so, and inside this loop, this is for the buying day. We will check for every buying day which selling day will be the best uh, to get the maximum profit. Okay, this is the buying day. I will write it also. And for each buying day we will run a loop that will start from the next day after the buying day, because, like, it's a very common sense thing only, that we can sell any stock after after the next day of buying that stock. Okay, so we need to start the loop from the next day of buying that stock. After that we will run it till the last day, because we can sell the stock at the last day also, so we can run it till last day also. uh, and after that we just need to uh, yeah. So here, now, this is for the buying day. Now the I value, this is for the selling day. The I value is the index of the buying day and the J value is the index of the selling day. Okay, so what we need to calculate is we need to see if the difference between the value of the selling day and the different and the buying day is more than our maximum profit variable value. Then we will, if that's the case, then we will uh, assign the difference between the selling day and the buying day value, the because that will have the more you know more profit than this maximum profit value, because it's more like it's more right. So that's why we need to first check if the maximum, if the difference between the selling day value and the selling day value will be prices of J minus prices of I. If the difference is more than the maximum profit value, it's the it's not the most optimal approach, but it does the work. So yeah, it solves the problem, so that's not the issue. And for this only, for this if that's the case, then we will need to change our maximum profit value to the new value, that is this, because this pair is giving us more profit. That's why we need to change it, the maximum profit value, to the new value, which is the which the new pair is giving us, which the new pair is giving us the profit. Okay, so now our maximum profit is changed if the new pair gives us more profit. Okay, so yeah, this is the problem. Now after running both the loops, now we need to return the maximum profit value. So yeah, now our problem is solved. Let us just try to run it. Yeah, it's accepted. Hmm, it's not the most optimal approach. Yeah, it's the time limit exceeded, because it's not the most optimal approach. It's running in order of n square time complexity, because here we are running a loop inside a loop, so that's why it's a very slow approach to solve this problem. So that's why for some of the test cases it will not able to pass, because the time limit got exceeded to run that test case, because it's too slow now. So that's why, see, if for 119 out of 211 test cases, 199 passed, because our approach is right. Okay, the approach that we are using to solve our problem is right, just that we need to optimize it to pass the other remaining test cases, other 11 to 12 test cases. For that reason we need to optimize it further. So yeah, this is the naive approach or the brute force approach. Now we need to solve it by using the another approach, that more that is more optimal than this, and will help to solve our problem. So yeah, so starting with the second approach. Yeah, so first what we need to do is we need to remove the inside loop. Okay, I will explain what I'm doing. So here the second approach, let me first explain it. Here what's the second approach is, we can, like, other than taking a variable called maximum profit, we can also create one more variable which will store the minimum value. That that we will first initialize at int max, because here this value will uh, like this value is the maximum value inside every C++ program. This word gives us the maximum value for the integer data type in C++. Okay, so first we need to initialize by this only, because like here for here this value will decrease only. We need to compare this value with every lesser value than this. So like if the value is less than this, then only we will assign the new value to this variable. So that's the reason, like we can use 0 also, but maybe our new value will be -1 and that will be the minimum, but it will not store because it will see that 0 is already the like not so minimum. Yeah, so you can just remember it that whenever we try to initialize any minimum variable, we need to assign it the value as int max, so that whenever we compare this variable value with some with some other value, that if this value uh, if the new value is lesser than this value, then assign that to this value. So that will help in that case. So that's why we need. And for maximum value, like whenever we initialize any maximum value, we need to assign the value as into minimum. For minimum value, we need to assign it the value as int max, and for maximum value we need to assign it as int min. Okay, so that's the case. Now we need to solve it by the another approach. So first, like after we initialize a new value, what we need to do is we need to look on to some like here for here inside this loop we will see if the new minimum value is lesser than our this minimum value. Okay, if the value is less than our this minimum value, that means the profit that we can achieve, uh, maybe we can achieve more profit by using that minimum value, because we need to buy the stock at the most minimum value, most least value, and for getting that least value only we are using this minimum value. So that's the reason we can, like that's the reason we are using this minimum value now. So whenever we will get more minimum value, we will use that minimum value only, but still our maximum profit will be the previous one only, because like it can happen that the minimum value that we get is the last value only, so we can't just like re-initialize this maximum profit value with some new other value, because if that the least minimum value is the last value, then we will not be able to sell that stock. So that's why we need to use the previous value only until and unless some new value which is the highest value, and which value will which uh, selling day value will uh, give us more profit. Until that pair comes until that pair comes we need to use the previous maximum profit value itself. So let us just see. Yeah, you are not able to understand, but I will still try to explain. So here what we need to do is we first need to check the profit. No, not the profit. We need to check if the new minimum value, if the value that we are iterating through is lesser than the minimum value. If that's the case, then we will initialize that minimum variable with that value itself. Okay. If it's not the case, then if it's not the case, and if the case is that 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 the new value that we got is that the new profit that we got, the profit that we got is more than uh, yeah, the profit that we can get now by this. If we are using this if for the buying day, but this else if we are using for the selling day. Okay, so if the selling day value gives us selling day value, the profit that the new selling day values, how we can calculate the profit by the difference of that value with the minimum value. So this is the profit. If this profit is greater than what, greater than our previous max profit value, then we will assign the maximum profit value as our new value, that is this value. Okay, so yeah, so this is the whole program. Now it's finished. Now this loop, now here we are using only one loop itself. Okay, so the time complexity of this will be order of n only. Okay, so that's why it will run faster than the previous one, the brute force approach one. This is a new approach to solve this, and it's the most optimal approach as well. Okay, so let us just try to run it now to see if it works or not. I will also try to dry run it to, yeah, it's running, and after submitting it also we can see it's giving wrong answer. Okay, so we need to start, sorry, because for each value we need to check the maximum profit value also, and for maximum profit value also we need to check the selling day value, and for selling day value and the selling day can be the last day also, so that's why we need to run it till the last element, not the second last. Okay, so let's just run it now. Okay, so yeah, it's the faster, it's accepted success. So now it's the all test cases passed. So yeah, this problem is now solved. I will try to dry run it like how it's working. Let me just use this example to explain. So by this, first we will need to see the minimum value. If this is the minimum value, this 7, first we will see that is it lesser than our minimum value. Yeah, it's lesser, because it's, of course, it's like every value will be lesser than this int max value. So that's why we are using this int max over here, so that we can assign our minimum value to any value to our this minimum variable. So yeah, so 7 is our minimum value now. Okay, after that we will move on to the second loop. for the second number, and for this number we will see if the minimum value is lesser than the uh, if this value is lesser than the minimum value. Yeah, so this value is of course lesser than the minimum value, so we will assign our new minimum value as 1. Okay, again we will move on to the next, and now we will see if this value is lesser than our minimum value. No, it's not, because our minimum value is 1 now and it's the 5. So now we will, now our minimum value is not lesser than, like our new value is not lesser than the minimum value. So now we will check the other condition that we have used over here to check if the to check for the selling day value. So for selling day value we need to check that if the value gives us profit, how much profit it will give. So our minimum value is 1 only, okay, that we have assigned. So here we will calculate the profit that we are getting by using the ith value as the selling day value. So here we can see the profit that we are getting is 5 minus 1, that is 4. This is 5 prices of I, and this is the minimum value was 1 only, so that's why we are getting the value as 4, and that is of course greater than our maximum profit value because we have initialized the maximum profit value as 0 only. So now we will assign the maximum profit value as that value itself, the profit value that we are getting. So now our maximum profit value becomes 4. Okay, so our maximum profit value is now 4, and again we need to run it to check if the value is, now we will see if the now we will see if our minimum value gets more and more lesser, and for each minimum value we will check after that if our maximum profit value is more. So now, like, what if we get our minimum value as lesser than even 1? Yeah, let's just assume that here there might be some other number, but here we got the minimum value as 1. So if the last element is minimum value as 1, and we have assigned our minimum value as 1 now, but still the loop will not run after that, and if this loop will not run after that, then we will not be able to assign the maximum profit to a new value, because this maximum profit value will of course need a loop to assign it. So that's why this will not be able to reassign, and this maximum profit value will only change if the maximum profit if the new value if the new profit value is greater than the previous maximum profit value. So it can't be changed very easily. Like it's very impossible to change without having some right pair to do that. So after that it will return the maximum profit value, and that's how our problem is now solved. So yeah, thanks for watching, guys. This approach will give us the time complexity as order of n, and the space complexity is also order of n only. Okay, so yeah, thank you so much, guys. Bye bye.